Morning. In this session, I would like to demonstrate the use of a calculator block. In fact, if you try to read this problem, so the environmental control facility has to decide on how to split the input into two outputs. In fact, based on the concentration of methanol in the input feed. For example, if the methanol concentration is above the allowable limit of 10%, then you are not permitted to let this stream into open atmosphere. Maybe you should route that through some processing units in order to meet this requirement. Of course, I might have taken some fictitious figures of 10% and 15%. Normally, this will be much more lower, right? Usually, you have some regulations with respect to volatile organic compounds that can be let out into atmosphere. Of course, whatever may be the number, we need to now know how to do this simulation in Aspen. Now, do you think the block that you are seeing, flow splitter, will have some kind of an intelligence to read what is the incoming concentration, and based on the incoming concentration, will it be able to identify how to route this into one of the exit streams? Now, I have already prepared this simulation, which is quite easy. So what I have done is I have used a flow splitter. This is the input stream. So depending on the concentration of methanol in the input stream, it has to put it all this into either the stream labeled low, in case if the methanol concentration is within allowable limit, and if the methanol concentration is above 10%, everything should go into this stream. Now, normally, most of our processes are supposed to work under steady state conditions, but because of certain disturbances in the process, when the steady state behavior is disturbed, this kind of things are likely to happen. So, the splitter will have to now decide accordingly based on the methanol concentration. Do you think the splitter has some kind of an intelligence to do this, take this kind of a decision? Now, whatever things that are not possible within this block can be done by using maybe a calculator block. Let me go into the problem definition after drawing this flow sheet. The components that I have decided that I have included are methanol and water. So temperature and pressure don't make much of a difference. Now initially I am taking one possible input, that is the methanol concentration is within allowable limit, right? So let us say this is what I have done. Then what I have done with respect to the splitter is I have decided to define 50% of the input flow should go into low, the remaining 50% should go into high. In any case, this should not happen because all the input streams should be either allowed to go into low or go into high, not some kind of a distribution. But we know we have to use some split fraction. Suppose if I say 0, concentration in the input is less than 10%. So only after checking it up, you need to do this. So in order to impart this kind of a logic, what we can do is we can include a calculator. You expand the flow sheeting options, click on calculator, say new, automatically it labels it as C1, calculator block 1. So what I have done in this input is I have defined two variables. The first variable is mole fraction of all in the input stream. You know how to define this. You can name it in any other way if you want. This is going to represent the mole fraction of methanol in the input stream 1. Now I am using it as an input variable. With respect to the calculator needs to get this information from the process simulator Aspen. Consider this is something outside Aspen. I mean, it's not part of Aspen or whatever you wish. Now I am going to read this value from the simulator or from the problem definition. And then I have decided, I have defined another variable labeled as SF, which is going to indicate the split fraction with respect to the stream flow. With respect to this variable B1, and the flow fraction with respect to low is what is meant by this SF, right? Then going to the next step, which is calculate. You can use either Fortran language or Excel to do these calculations within the calculator block. Here is, I have already information about the value of fraction of methanol from the simulator by importing this value from the simulator. Now the calculator block is trying to check whether the mole fraction of methanol obtained from Aspen is within or is less than or equal to 0.1. You know how if statement is going to work. If this statement is true, then this particular statement will be executed. Otherwise, this statement will be executed. So in case if the mole fraction is less than 1, because I am defining the split fraction with respect to the stream labeled low, I would like to put everything into labeled low because it is within tolerable limit. Otherwise, if it is more than 0.1, I have to put it into the stream labeled high. Now remember, we have defined already the split fraction within the block as 0.5. Obviously, if you don't use this calculator block, the simulator would be putting into the stream labeled low and the remaining 50% would be put into the stream labeled high. Now we know already what is the composition of methanol. Anyway, let me run this problem and see what will be the result. Now according to our expectation, what should happen? Because the methanol mole fraction is less than 10%, everything should go into low. Right? You can see everything is routed. 1 kilomole per hour of the feed that is going into the low because the methanol mole fraction is less than 10%. Now nothing is going into the stream labeled high. Though we said split fraction is 0.5, the split fraction originally by the block originally defined in the block splitter is now being rewritten by the logic that we are using in the calculator block. Now let me test this with one more example by varying the composition. Let us say the mole fraction of methanol is more than 10%, for example 0.15. This is 0.85. Right? Now what should happen? Everything should be routed through the stream labeled high. Let us see when we run this problem. Again, look at the stream summary. Now you can see everything is going into the stream labeled high. Nothing is going into low, like what you have seen in the previous case. In the previous case, everything was routed through stream low because the methanol concentration is within tolerable limit. So this is how we were able to incorporate some kind of intelligence or logic into the splitter block, which is not part of its regular calculations. The model doesn't have this kind of a capability. So we were able to incorporate this extra capability by using a calculator block. Let me once again go back to the input and in addition to this Fortran, if you are comfortable with it, you can also, this defined part will have to remain the same. You need to define what are the variables that you are going to use in the calculator block. This part remains the same, but during the calculation, instead of Fortran, I can click on Excel. Now you can see automatically Excel sheet is open. Then open Excel spreadsheet. You need to do certain things before you can link Aspen with Excel. I think this information can be obtained from any standard installations. Then once you go into this Excel, if you have done enough linking between Aspen and Excel, you will be able to see this Aspen simulation workbook and add-ins. So I am clicking on add-ins. When you click on add-ins, you will be able to, you have already defined in Aspen, right? For example, if you want, you can also add a comment, something like mole fraction of methanol in input. You can make it slightly readable for the benefit of you users. Let me also write is equal to, for some, because now this particular cell, I would like to print the value of mole fraction, which is read from Aspen. So this cell is reserved to print the value of mole fraction of methanol. Similarly, now what is the calculation I would like to make? Let us say the split fraction equal to. Now unfortunately the split fraction cannot be defined with respect to the low stream, cannot be defined with a uniform value that depends on the mole fraction of methanol. Let us say this I am using again the if loop in Excel. If you know already we have this particular mole fraction is now the value of this mole fraction is available in this cell, right? Which is what is this cell A2. You can either use MF or even A2, right? This is the cell I am referring to. Then if it is less than or equal to 0.1, so if this logical expression is true, a value of 0 will be reported, otherwise a value of 1 will be reported. This is the way Excel operates, right? Now, we don't know until we run, it may not be knowing the value of mole fraction of methanol because right now we have not run the problem. Now this value, I am going to, whatever value that I am calculating, now I would like to put this cell to represent the value of SF, which is actually calculated by this logical expression. So this cell will contain the value of whatever value that I get in B3. So whatever value that you are able to see here will be appearing here. Now with this, probably you can close down this window. So this is what we have done. Now let me run this problem. Now remember, Fortran is no longer active. I am using Excel to do the calculations within the calculator block. Will hold good whether you are using Fortran or Excel. Now what is the mole fraction of methanol in the input? Actually you can see we have defined 15%. Now this split fraction is not, what would we check, less than or equal to 0.1. 0.15 is not less than or equal to 0.1, that's why it is reporting 0, right? Otherwise, okay, once again you can go back and change this definition to less than 0.1, let's say 0.08, maybe 0.92. This is another set of field. So once again, if we run this problem, now what will happen to this calculator block and calculate? So there is some issue with respect to our Excel if statement. Split fraction, what did we write? Sorry, this is not A2, sorry, this is B2. That's why it is not, it is always considering the mole fraction as a 0. This I should have corrected. Right. Now let me run this now. Initialize. Let's see. Now what should happen? Ideally, because the mole fraction is less than 0.1, it should report a value of 0. Not exactly 0. No? Let us see, calculate. So you can see the mole fraction of methanol is obtained. So 0.08 is less than 0.1. So the expression is true. The first value which we have written as 0 is reported. So if you look at the stream summary, now you can see because the split fraction with respect to low stream is set to be 0, then we got everything routed through 1. In fact, we should have written the other way. Just 1 second, I will go back. I think there is a small issue with respect to your calculator block. We did not write it properly. This is where we are calculating an Excel spreadsheet. See, probably I should put it as greater than 0.1, then if the expression is true, less than or equal to, I'm not sure, let's see, if this expression is true, I think the first value will be executed, which is 1. The second value will be if the expression is false. Right? Now you can probably run this problem. Yeah. Now you can see the split fraction originally defined as 0.5 is made 1 with respect to low. So everything will be routed through low, nothing into high, as we have seen from Fortran statement. Let us test this with another example. What will happen if the mode fraction is more than 10%? 0.12, 0.88. Now everything should go into the stream labeled high based on whatever logic that we are using in Excel. Now you can of course see here itself, calculator block itself. That statement, I think the if statement I am not writing properly in this, that is the problem. So this value is not even B2, that is the problem. This is B1, that is the mistake we are committing. This is B1, right? So automatically you can see, because this mole fraction is not less than 0.1, if it is, that's why it is sending 0. Anyway, let me, I think this is the mistake I have done. Please be careful. The value of mole fraction is available in this cell B1. I have been writing it as A1, B2. That is the mistake we had. So now let us run this problem again. Reset and run. So you know the mole fraction is more than 0.12. So you know where the output should be routed. So look at the stream summary. Now because the mole fraction is not within tolerable limit, the mole fraction is represented, the stream is going into high. Take another example and show the mole fraction less than 0.1 and see whether it is doing the calculations appropriately or not. Now let us look at the stream summary. Now you can see, because the mole fraction of methanol is within tolerable limit, everything is being sent into the stream labeled low. So now the splitter is able to obtain some kind of a logic through the use of a calculator block and decide accordingly where to route the exit. Either it has to send it to low or high based on the mole fraction of methanol. So this kind of an additional intelligence or additional calculations which are not part of the regular block can be done using a calculator block. In fact, in some of the previous problems we said, if you go into this calculator block, now you can probably communicate some of the answers which are not part of your Aspen, like percent XSA, the number of flue gas generated, ratio of moles of flue gas generated to moles of fuel burned. You can do those calculations in Excel and probably communicate your results. So the communication can happen using either Fortran or Excel. So depending on your convenience, probably you can use either of them while using a calculator block. But remember, if you just install Aspen and Excel, this may not work. So you need to do certain installations in order to link Aspen with Excel. In other words, normally when you open Excel, you will not be seeing this simulation workbook. Unless you see this workbook, you will not be able to use Excel calculations and link it with Aspen. So this procedure is of course not that difficult. You can, some YouTube videos are also available how to link Excel with Aspen. Remember, this has to be done before you would like to use calculator block using Excel to do some calculations. So with this, again, I would like to end this session. You can practice maybe taking suitable examples.